Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count symmetric integers. So we know that if the number has an odd number of digits, then they are never symmetric. If they have an even number of digits, however, then we need to check if the sum of the first half of the digits is equal to the sum of the last half of the digits. And finally, we want to return the number of symmetric integers in the range from low to high. So if we look at this example, there are 9 integers between 1 and 100 that are symmetric. And if we look at this example, there are 4 integers that are symmetric between 1200 and 1230. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can iterate through every number from low to high. And in each iteration, if the number happens to have an odd number of digits, then we can just move on to the next number. If it has an even number of digits, then we will divide the number of digits by 2 and then find that middle value, and then we will find the sum from the first half and the second half. The first half we will iterate from the beginning to the digit before the middle value, and the second half will be the sum from the middle value all the way to the end, and then we'll compare if these two sums are equal. If they are, then we will add 1 to the result, and then in the end we will return a number of matches that are symmetric. So let's go over this example real quick. So first we start at 1200. We realize that the middle value is 2 and 3 plus 0 are not equal. We move to the next number. 3 plus 1 is not equal. In 1202, 3 plus 2 is not equal. However, in 1203, 3 is equal to 3, and then we move on. In 1204, 3 is not equal to 4, and then so on, all the way to 1209. And then 1210 is still not equal because 3 is not equal to 1. In 1211, 3 is not equal to 2, and then 1212, we find that there's another equal one, so we can add it again. And in 1213, not equal. 1214, not equal. 1215, not equal. And all the way to 1220, we will not find anything equal. And then 1221, we have found another equal one. And as we keep searching, the only other ones that are symmetric, meaning the first half and second half are equal, is 1230. And we have reached the end, and we've realized that there's 4 symmetric integers, so we can return 4 as our result. So the time complexity would be O of H minus L times D, and H stands for high, L stands for low, and D stands for number of digits, because we will have to loop through everything from high to low within the range, and in each of these iterations we will have to iterate through the number of digits to calculate the sum of each of these numbers. And the space complexity will be O of 1 because we are not using any extra space. So now let's get to the coding part. So first we'll initialize result to 0, and then we'll loop through low to high. So for num in range low to high plus 1, and we will temporarily set num to a string. So num equals string of num, and if the length of num divided by 2 has a remainder, then that means it's not even and it's odd, so we can continue. And now we'll find the middle value if it is even, so length of num divided by 2, and sum 1, which would be the first half. So for I in range mid, so we will look up to mid and we'll add the sum accordingly. So sum 1 plus int of num of I. And we will do the same for sum 2. So sum 2, 0, and then we will do for I in range mid to length of num. And then sum plus int of num of I, sum 2. Sum 2 plus int of num of I. And if sum 1 is equal to sum 2, then we can add 1 to result. And in the end, we'll return the result. See if it works. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them down in the comment section, and I hope to see you all again soon.